Hello everyone, I am Dr. Arun Sharma. In this video, I will explain the mole concept and molar masses. First of all, we will go for the background of this concept. Then we go for the definition and calculation based on this mole concept and molar masses. So this is the definition of mole concept and molar mass. First we go for the background. Why it is required? As we know that atoms and molecules are extremely small in size and their numbers is in even a small amount of any substance is really very large. To handle such large numbers, a unit of convenient magnitude is required. Just as we denote 1 dozen for 12 items. If there are any 12 items, we denote it by 1 dozen. 1000 grams, we denote it by 1 kilogram. So we use the idea of mole to count entities at the microscopic level, that is atoms, molecules, particles, electrons, ions, etc. In SI system, mole was introduced as seventh base quantity for the amount of a substance. The mole is the SI unit of amount of a substance, and we know that in 1 mole it contains exactly 6.022140076 into 10 to the power 23 elementary entities. This number is the fixed numerical value of the Avogadro constant. It is represented by the symbol Na when expressed in the unit per mole and is called the Avogadro number. The amount of substance of a system is a measure of the number of the specified elementary entities. An elementary entity may be an atom, a molecule, an ion, an electron, any other particle or specified group of particles. It may be emphasized that the mole of a substance always contains the same number of entities, no matter what the substance may be. In order to determine this number precisely, the mass of a carbon 12 atom was determined by a spectrometer and found to be equal to 1.992648 into 10 to the power minus 23 grams. So this is the atomic mass of carbon 12 atom. So this is the atomic mass which is determined by the help of mass spectrometer. Now, knowing that 1 mole of carbon weighs 12 grams, as we know that 1 mole of carbon there are 12 grams, that is the atomic mass of carbon in approximately units, that's 12 grams. So the number of atoms in it is equal to 12 grams per mole, that is in 1 mole there are 12 grams divided by the atomic mass of carbon as determined by the mass spectrometer, that is 1.992648 into 10 to the power minus 23 grams per 12 carbon 12 atom. So we get the answer, that is 6.0221367 into 10 to the power 23 atoms per mole. So in 1 mole there are 6.0221367 into 10 to the power 23 molecule atoms of carbon. So this number of entities in 1 mole is so important that is given a separate name and a symbol, and it is known as Avogadro constant. So Avogadro number you can also write, that is Avogadro constant. So the number 6.022140076 into 10 to the power 23 is known as Avogadro number, and it is often denoted by the symbol Na. So this is the concept of mole concept. This is called the mole concept, and the mass of 1 mole of substance in grams is called its molar mass. Example, the molar mass of water is 18.02 grams per mole in 1. So we can write that in 1 mole of water, the weight of 1 mole of water, that is 18.02 grams. And in the same fashion, we can also say that molar mass of sodium chloride, that is 58.5 grams per mole. So in 1 mole of sodium chloride there are what is the weight of the sodium chloride, that is 58.5 grams. Now Based on this concept, here some numericals are given. First numerical is how many moles of iron are present in a pure sample weighing 558.45 grams. So we have a sample of iron and its weight is 558.45 grams. Now we have to calculate how many moles of iron are present. As we know, the molar mass of iron is 55.845 grams per mole. So in 1 mole of iron there are how many grams of iron? 55.845 grams. So in terms of moles, if you want to calculate, so you divide the weight given of iron, that is the pure, that is the sample of pure iron, divided by its molar mass. Because the sample is pure, so no impurity is found, so you have to divide it by the molar mass of the iron, that is 55.845 grams. So you get the answer in terms of in mole. So there are 10 moles of iron present in that in the sample. Now in the second numerical, how many molecules of water are present in 36 grams of water? So 36 grams of water in 1 mole, there are approximately 18 grams of water is present. So that is we can write that is here 2 moles of water is present in 36 grams. That is we can write that is 2 moles of water. So in 1 mole of water there are 6.023 into 10 to the power 23 water molecules, as it is the value of Avogadro number, and it is a the value, that is the constant for in each 1 mole of quantity, the number of the entities, as we have explained earlier, that is 6.023 into 10 to the power 20, that is called Avogadro number. So in 2 moles this value is multiplied by 2, so you get the answer finally, that is 12.046 into 10 to the power 23 water molecules in the 36 grams of water. Or we can write that is in 2 moles of water there are 12.046 into 10 to the power 23 water molecules. Thanks for watching this video. Please subscribe this channel. If you have any questions, please feel free to contact me. My contact details are given here. Thank you very much.